From analog capture and the dawn of the digital age to the latest technologies and wonders of our modern era, the progress you've made has fueled innovation, inspired future generations, and changed our world. It's time to build the future together.
Please welcome to the stage Vice President Global NI Sales and Marketing, Emerson Test and Measurement, Luke Schreier.
Good morning, everyone, and welcome to day 2 of NI Connect. It is such a pleasure to be here and once again see so many new and the familiar faces that we love coming back. And I also this year want to personally welcome all of the AI agents that are joining us today. Listening, transcribing, summarizing, it's a real treat. And also let's not forget the AI agents managing the AI agents. I know we'd all be nowhere without the support of our bosses, agentic or otherwise. But I do promise the tokens spent on NI Connect this week will be well worth it. In all seriousness, thank you for being here. Day 1 yesterday was big. Big ideas, big ambition. We had some big genius of the and energy up here. If you didn't have a chance to see the keynote live yesterday, definitely check out the recordings online. We talked about our legacy, about a future that's arriving fast, and about how the NI platform is the most AI-ready platform in test and measurement. And most importantly, we showed how we're embracing innovation while building on a sturdy foundation, and that the future is full of potential. But let's be clear, this is not a mission accomplished moment. This is an inflection point. One that can either overwhelm us with complexity or really inspire us to reimagine productivity. And I know this audience well enough to bet on inspiration. So whether yesterday left you energized, or maybe quietly thinking, I might need to process that a little bit, today is for you. Because today, we're grounding it in reality. What's happening right now, and what innovation and productivity actually look like in practice. At the center of that is you, the engineer. Agentic engineering may be the future, but we will always need the human engineer. For decades, when you've faced problems no one has solved before, we've been there to help figure it out. Some things have changed. You've got scale, speed, complexity, but some things haven't, like the need for rigor, for judgment, and for engineering confidence when the stakes are real. And looking across this room, I see many of you in industries that move carefully by necessity, where the environments are unforgiving and margins are really thin. As they say, failure may not actually be an option for some of you. Productivity and progress look different depending on where you sit. But the constant is this. You choose NI because we move forward with you at your pace. And today, you're deploying millions of measurement channels to design, prototype, and deploy innovations safely and cost-effectively all around the world. You're enabling astronauts to orbit the moon, advancing vehicle autonomy, and developing life-saving medical devices for people to live longer, healthier lives. We regularly do things that were previously thought impossible. Why not expect we can evolve what's working and shift the paradigm at the same time? But I want to come back to our theme this week, productivity. It's not productivity as a buzzword, but it's productivity as speed to insight. How quickly teams move from complexity to confident decisions. adapt as requirements change, and scale what works without rebuilding from scratch every time. Now, yesterday, you heard Charles and Kevin on this stage give a strong, clear endorsement of our platform-based approach. You also heard them acknowledge something important. Sometimes third-party tools do things better. That's not a contradiction, that's intentional. For 50 years, NI has optimized for flexibility, giving you the power to choose which technologies help your tests run faster and get your product to market sooner. That's why we helped create multi-vendor consortia like PXI and Ivy. It's why we embraced ANSI C alongside LabVIEW. It's why we built the instrument driver network, still with more than 10,000 drivers available for download, because of course you're going to use box instruments for some measurements. It's been a while, but you might remember that NI's first product was a GPIB interface, because connecting the best technologies together is who we are, and you need the best technologies to succeed. Test and measurement systems can last decades, and as Charles reminded us, they must be built to last. AI, LLMs, and new development approaches are moving quickly and for good reason. The opportunity to change how work gets done is enormous. But in test and measurement, speed alone is not the goal. Precision, reliability, and trust are non-negotiable. That's not hesitation, that's engineering. Now today, you're going to hear from teams leveraging the NI platform to reimagine productivity across some very different industries. They've all faced rising complexity, tough competition, digital transformation, and the hard question of when to keep going or when to change direction. Each has their own genius of the and success story, and I'm excited to share them with you. So let's dive in. If there's any industry where the opportunity and responsibility of innovation is unmistakable, it's defense. The pressure to produce more, faster, while also fielding next-generation capabilities is not theoretical. It's happening now. But moving fast at the expense of confidence, mission readiness, or human lives, that's not an option. One company meeting that challenge head-on is Lockheed Martin. For generations, they've been at the forefront of sophisticated defense technology development, and we've had the privilege of working alongside them through many incredible test and measurement transformations. But what they're doing now with their data is unlocking a new level of potential. Please join me in welcoming Nicole Loki from Lockheed Martin. Welcome, Nicole.
My pleasure, Luke. Thanks for having me.
Okay, so Lockheed Martin is very well known in the defense community, but we have a diverse audience here today and online. So give us a brief overview of the company and the mission.
Sure. Lockheed Martin is a global defense technology company driving innovation and advancing scientific discovery. Our all-domain mission solutions and 21st century security vision deliver transformative technologies that deter threats and safeguard America and its allies so we can achieve peace through strength. We aim to build a more resilient, advanced, and interoperable defense industry, working with industry and commercial partners to deliver cutting-edge capabilities faster and more affordably to our customers.
Well, and as the very cool video is showing, Lockheed Martin does a lot of different things with different teams. So tell us about your team.
Missiles and Fire Control is one of 4 business areas within Lockheed Martin. At MFC, we focus on advanced combat missiles, rockets, sensors, and manned-unmanned systems for military and defense customers globally. We do business in more than 50 countries, and we have more than 50 product lines and services. If you follow the news, you may have seen that recently we partnered with the Department of War on several landmark framework agreements to accelerate the production of critical defense programs. We have to dramatically accelerate the production of critical munitions, and we're doing that by leveraging next-generation technologies to build at speed and scale. Over the years, we've received many moving letters from servicemen and women currently overseas that see the life-saving work of these products in action. Their powerful words and notes of thanks remind us that what we do every day matters.
Yeah, and thanks so much for sharing that. And I'm sure with everything that's happening globally right now, you've got to be feeling a lot of pressure.
Well, we have to deliver. Geopolitics are tense right now, and our ability to field interceptors on demand is really important. We've never seen as much need for our systems as today, driven by proven battlefield performance and the urgent need for speed, precision, and scalability. To meet that demand, we were the first in the industry to announce the framework agreements under the DoW's acquisition transformation strategy. We're set to triple or quadruple production capacities for key programs like PAC-3, THAAD, and PRISM. We're planning multi-billion-dollar investments over the next 3 years to expand our production lines and to build and modernize more than 20 facilities. This will upgrade our existing systems and incorporate advanced manufacturing techniques, production lines, tooling, and plant layouts.
Well, we have seen this shift kind of up close, having worked directly or through partners on many of the programs that you just mentioned. And I just say for a long time, what was in place just kind of worked. And now, as you're forced to push for all this greater scale, how do you stay productive and manage the risk there?
Well, we not only need to increase our quantities, but we also need to produce new technology faster. Development speed and accelerating the transition from lab to field allows us to adapt to faster threat cycles and keep innovation at the forefront of our mission. So we bias towards readily available off-the-shelf technology, like the NI platform, to reduce both lead times and risk. And finally, there's automation and data analytics, which can sometimes be a challenge. We have massive amounts of test data that we need to turn into actionable insights to design, change performance, and maximize reliability and throughput.
Yeah, I'm sure many of us have been in the same room. If you're going to increase production quantities rapidly and field new tech quickly, data is essential. I think Charles called it the new oxygen yesterday. It is really the critical path to insight. And we've had some great collaboration around SystemLink to help, right?
That's right, Luke. Leveraging the data harnessed by SystemLink, which it powers our intelligent factory, we're driving yield improvements across legacy product lines by optimizing test capability and proactively addressing test issues which could affect yield. In one recent example, we were able to evaluate 300,000 individual measurements and optimize 22 test steps in a matter of just hours. That, without SystemLink, would have taken us weeks. This resulted in an immediate 16% improvement in first pass yield. That means more systems in the hands of more users faster. Also, we have some off-the-shelf usages in our production test system designs that have decreased cycle time for obsolescence modification and for maintenance actions.
Yeah, and if I may also add, just because I sat through some of those early discussions with your team, a critical part of your success was the enterprise-wide alignment. Your leaders were really clear that digital transformation, data, model-based engineering mattered, and then they backed that with support. So tell us how that shaped the program and your progress.
Well, with all the market pressures, we need to lead the way on the best engineering practices. In 2024, we announced our ModStar initiative that leverages model-based engineering to deliver products faster with planned modular upgrades. This provides early and evolving capability to our customers. As all digital program models mature, ModStar is building a digital hardware catalog of common product architectures and proven hardware solutions, complementing Arise. That's Lockheed Martin's digital engineering environment. ModStar and Arise together enable engineers to tap into our proven all-digital designs from across Lockheed Martin to accelerate development and boost maturity while saving time and money, all of which we can pass along to our customers. Teams can also search for digital models of similar products that have flown in a tactical environment and then select the parts that meet the requirements to generate a starting program model. This significantly accelerates the development process, bringing our customers the best technologies on the best possible timeline.
So what I hear you describing is a practical way to approach model-based engineering. You're identifying the components or models that are already proven to work under the right conditions, and then using them deliberately instead of reinventing the wheel. You also made it sound really easy, which was, I'm sure it was not. I'm sure you had to have some standards to make that all possible, though.
Well, that's right. In support of ModStar, we needed a standard user interface for data. This data also needed to be automatically analyzed through production analytics as part of our transformation initiatives. Your team embraced that request that we made to all of our partners in our ecosystem to build a common hardware architecture that plugs into whatever we need. You've worked hard to match your technology to what's in our parts catalog, allowing us to maximize both pace and performance.
Well, as we said earlier, your team's under a ton of pressure for advanced capabilities that deliver every time all around the world, and we appreciate the opportunity to help support the mission.
Thanks, Luke. NI is a trusted partner for Lockheed Martin. You help us meet our evolving threats and challenges. You keep pace with the growing demand and ensure our customers achieve the best performance on the fastest possible schedule. We appreciate your partnership and we look forward to working together in the future.
Thanks so much for being here, Nicole.
Thanks, Luke.
Appreciate it. So, Nicole has a tough job. It reminds me of the old project management triangle, that suggests you can optimize around project scope, timeline, or cost. But the cautionary tale is that you only get to pick two, and usually at the expense of the third. As we avoid falling into that trap, it's the scope category that's interesting lately in the automotive industry. Advanced driver assistance systems, or ADAS, are a huge increase in scope for automotive test applications. They rely on a central electronic control unit, or ECU, to form the brain of the ADAS system. It's going to manage the radar, the cameras, ultrasonic sensors, and then domain control for the whole car. As vehicles become more automated, that brain is being asked to do even more. And Valeo is at the forefront of creating the next generation of ECUs and shaping where mobility goes next. So to give you a closer look at how they're progressing along that journey, please join me in welcoming System Validation Manager for Valeo, Veet Naruda. Veet, you got a round of applause there. That's great. Thanks so much for being here. We love validation engineers here at this conference. They are truly the center of making new technology like ADAS systems come to life. Tell us a little bit about your team and what they're working on.
At Valeo, I am part of the DETECT team. We validate ADAS systems. As the system grew, complexity increased quickly. We add more sensors, more hardware, and more connections. Each new part adds more to test. The system gets smarter, but validation gets harder. And the scale is growing fast. As the vehicles move to the higher autonomy, ADAS content can grow up to 10 times. Valeo has already produced more than 1.5 billion ADAS sensors over the past 30 years and expects to produce 1.5 billion in just next 5. That kind of growth shows up across the entire system. More sensors, more data, and more interactions to validate. And by 2030, more than 90% of vehicles will include these systems.
Yeah, I mean, the growth is really staggering. We're talking billions of sensors. And from the driver's seat, we experience the results of that almost without even thinking about the validation behind it. These systems just work. So how do you make that possible at this scale?
As the system evolved, validation became harder. Our early test methods worked, but they didn't scale. As complexity increased, the effort increased too. We had to manage test software alongside the production software. We also logged data in the vehicle and tested it later in the lab. Then moved to the hill. Connection the real ECU to a simulated environment. But as the system kept growing, the effort grew with it. We could test it, but it was hard to scale. At some point, you can't keep adding custom systems for every new requirement.
I'm sure a lot of teams in this audience have hit that moment. You're not just going to keep stacking one-off systems together forever as you grow. Eventually, you're going to hit a wall, and productivity has to come from changing the approach. So what did that turning point look like for you at Valeo?
We step back and ask a different question. Not how do we build better test benches, but how do we increase productivity without adding more overhead? The answer was in architecture. We standardized on NI PXI platform. We use direct injection hill as the base of our validation. With the same hardware, we can extend into the simulation with different providers. This gives us flexibility for different OEM needs. We build a platform that can scale with the program.
Well, then once you had that foundation in place, what kind of impact did you start to see?
Two things made the biggest difference. First, platform reuse. We use the same PXI system in the vehicle and in the lab. This reduced variation and lets us reuse the same setup across the program. Second, the performance. With direct injection here, we test the ECU using production firmware. We no longer build separate test software. Time to first test improve. Coverage improve. Engineering effort shift back to validating the system. We didn't scale, adding more custom work. We scale by building on the common platform.
We should probably put that on a brochure right there. We definitely like the sound of that. Less time and less complexity to handle the increase in scope. So now how has that changed the way you think about your validation strategy going forward?
It means we can sustain productivity. As the ECU becomes more advanced, our validation approach keeps up. We move faster, we increase coverage, and we support growing program demands without adding the same level of effort. That's what the productivity looks for us. A validation approach that scales with the system.
Well, as I said, that's just beautiful. So taking a look ahead, anything you can share with us about how you're thinking about AI, topic of the week?
Okay, AI is becoming a bigger part of these systems, especially for the perception and decisions. But for us, the priorities stay the same. These are safety-critical systems. We focus on validating AI with the confidence, and we meet strict requirements for safety, security, and data privacy. We have been building and validating ECUs for decades. That experience helps us to bring AI into the production in controlled and reliable way.
Yeah, and I'm willing to bet that perspective resonates with a lot of people here. You want to push the capability forward with AI, but you have to stay grounded in safety. I think that's a great genius of the and example. Veet, thanks so much for being here.
Thank you, Luke.
Appreciate it. Okay, so far we've spent the time this morning with the teams advancing engineering at industrial scale, work that has already shaped critical industries. Now let's turn a different direction to a different moment in engineering when new capabilities begin to take shape. At the frontier, productivity means moving ideas far enough forward that they can potentially transform an industry. Now, few areas matter more to us in everyday life than energy. As demand accelerates and the need for clean, reliable power grows, expanding what's possible in energy production becomes essential. And that's exactly where Zap Energy is focused, pushing fusion power from theory toward reality and building the control and validation required to make it run in the real world. So let's meet them. Please join me in welcoming Marvi Matos Rodriguez from Zap Energy. Okay, Marvi, welcome to NI Connect. Give us an intro to Zap Energy and your mission.
Well, thank you, Luke. At Zap, we are making commercial fusion energy a reality. Our work is about reliability and scalability, combining bold physics with disciplined engineering to move from promising research to consistent megawatts.
That's good. And from what I understand, you're bringing an important professional background into fusion.
Well, yeah, before Zap Energy, I worked in the aerospace industry, where I learned systems engineering, strict safety margins, and how to deliver under pretty tight constraints. Now I get to apply those skills to a universal social good.
Okay, we were talking backstage. This is a very smart audience that we have out here. Many likely know that fusion's been studied for decades. So what's making your approach different now?
Yeah, it's an era of fueled innovation with great advances in computing and materials. But for most approaches, they use massive superconducting magnets or lasers to confine the plasma, which is used as the fuel source. Those machines are enormous and expensive and also hard to scale. They're in the billions. Instead of external magnets, Zap actually uses strong pulses of electric current to create a magnetic field. This squeezes plasma inwards while shear flow keeps it from wobbling apart. The result is a modular compact device that is easier to scale to commercial scales.
I'm not going to try to imitate the wobble, but if I will restate from an engineering standpoint, I think the breakthrough here isn't just the physics itself, but it's also this ability to orchestrate these complex integrated systems in a way that's reliable and repeatable, and that's what creates the usable energy. Is that a fair way to describe it?
That's right, pretty smart. So, and the simplicity of the physics approach, literally a line of plasma a few meters long, means we are already building the power plant around that fuel source. For the past 24 months, we have been ramping up operations of our subscale test plant called Century. Century lets us operate all the critical systems of the fusion power plant together, pushing it to higher performance levels over time. So we're working with extremely high temperatures, extremely high voltages, thousands of kilograms of flowing liquid metal under vacuum running over and over again in rapid succession. It's kind of wild.
Yeah.
Each shot carries up to 20 times the peak current of a lightning bolt. Century lets us validate the full system so that we can move quickly towards grid-ready power. The moment plasma efficiency passes key thresholds, Q equals 1, we want power flowing to the grid as soon as possible. A single device is designed to generate about 50 megawatts, enough energy to power a small city. Adding more fusion modules means scaling the system to meet much larger demand. At 10 feet long, with virtually no emissions and on-demand operations, our fusion modules can be located almost anywhere without the practical limitations of virtually any other equivalent power generation technology. It's pretty cool.
Yeah, it sounds really cool. I hope you were all ready for that at this hour of the morning. That's amazing. It's really impressive to hear how much control you've been able to build at this point. But I'm sure as you move from the physics into the real-world operation, that control and safety just become like the most central challenge. What changes as you're making that transition?
Yeah, so fusion energy is often referred to as the holy grail of energy sources. It's safe, it's clean, it's carbon-free, replicating on Earth, the same phenomenon that powers the sun, well, is pretty difficult, pretty hard to do. So as you can see by this burn electrode that we have right here. So we approach this from a couple of perspectives, right? Engineering perspectives too. On the technology side, every component and control decision must obey physics that exists almost nowhere else except for the stars. For us to control means coordinating large bursts of energy measured in microseconds inside a brutally demanding environment. On the engineering side, we partner with Scythe Systems to meet that difficult standard.
Please join us in welcoming Joe Spinozzi from Scythe Systems.
Hi. Hey, Luke.
What's happening? Okay, Joe, it's great to have you here. You've, of course, been our partner at Scythe Systems for a long time. What role does Scythe play in enabling this kind of work?
Thanks, Luke and Marvy. Turning extreme physics like this into a safe and reliable commercial system is not your everyday project. ZAPP needed us to help them synchronize 24 high-voltage pulse power modules to control the current flow that goes through the magnetic field. That requires extremely precise timing, fast processing, custom logic, and safety monitoring. And as an NI partner for over 25 years, we knew right away that the NI Compact Rio would meet these requirements, as well as give us the flexibility to add signals and channels as the system evolved.
Well, that makes a lot of sense. You know, Compact Rio has been around for more than 20 years, and we have seen some amazing solutions built on it. The combination of determinism and flexibility seems like a critical item here.
Oh, it is, yes. So we partnered with ZAPP Energy, and we built the control stack on Compact Rio and LabVIEW, using the FPGA to coordinate all 24 subsystems with precise deterministic timing, and we were able to get down to about 1.6 nanoseconds of trigger skew among all the channels, which ensured that the pulse power modules were completely synchronized when they fired. And while we started with almost entirely high-speed digital I/O modules in this application, the breadth of C-Series modules empowered us to expand to solve problems regardless of what sensors or signals or processing came up as the project progressed. The final result, a precision control system for a real fusion device. So by building on this common, flexible platform, we are able to shave months off development time while keeping the system ready to evolve as needed to evolve with ZAPP's design.
Okay, well, as that work continues to evolve, is there anything else we could be doing to make it even easier for you, Joe, to build systems like this?
Well, the new I/O modules you've recently released are great. But you know me, Luke. You know I like to go off script a little bit. So you know I'm going to ask, when are we going to see some updated Compact Rio controllers?
Wow, I didn't expect this at all, Joe.
I'm taking advantage.
I'm so glad you asked. We don't have anything to announce today, but I do want everyone to know we are working on the next generation of serial controllers, so stay tuned. Compact Rio is a core part of our platform, and it is getting a lot of attention in R&D right now. So back to you, Marvi. What's next on the path here to sustainable nuclear energy?
We have a long road ahead of us to advance towards a fusion reactor that can sustainably deliver power to the grid. SIDE and the NI platform are critical infrastructure for that journey. To get to our commercial megawatt facility or plant, we'll keep on pushing our technology to new levels until commercial fusion helps us power the planet.
Amazing stuff. Thank you both so much for being here. Thanks for coming. Yep.
Thanks, Luke.
Appreciate it. Thank you, Mary. Yeah, it's great. In case anyone's wondering, the burned electrode is not still burning. That's stage magic up there. So we're all safe. So you just saw another great example of how this platform-based approach isn't just about measurements. It's also about very precise control applications. Oftentimes, the challenge to getting work done productively is tackling both of those things at the same time. Now, one place the combination of test and control truly matters is in space. Over the last decade, we've seen a major shift in the aerospace industry. Companies are moving faster, they're iterating more quickly, and expanding access to orbit. But once you fire up a rocket, the margin for error disappears really quickly. Every subsystem, every component, every separation event, and engine ignition has to work nominally, when it counts. There are no do-overs, and before anything ever flies, it has to be proven on the ground. Our next guest represents a company helping redefine Europe's role in commercial spaceflight. Please welcome Pablo Gallego from PLD Space. Good. Pablo, welcome to NI Connect. So for those who may not be familiar with PLD Space, tell us about who you are and what you're building.
Thanks, Luke. It's great to be here. As Senior Vice President at PLD, I help drive the company's commercial and technical growth. PLD Space was founded in Spain in 2011 by 3 aerospace engineers with a bold vision to build a family of reusable rockets, like this one, that could provide a more sustainable and cost-effective to space. What started as a university project has grown into a company of more than 450 engineers and specialists working across design, testing, manufacturing, and launch operation. In 2023, we successfully launched Miura-1, becoming the first private European company to launch a rocket of this class. This milestone marks a significant advance for both PLD Space and Europe private space sector. We are now focused on Miura-5, designed to provide dedicated launch services for small and medium satellites with payload up to 1,000 kilograms, dedicated for customers worldwide.
Yeah, and that's just an incredible amount of progress in just over a decade. But I'm sure before any launch vehicle leaves the ground, it's got to go through just a massive amount of testing. So talk us through your testing philosophy over at PLD Space.
Yeah, testing is key to everything we do at PLD. At PLD Space, we follow the test like you fly approach, in which we test all the subsystems of the launcher to their limits and the real flight condition to ensure that the launcher will function correctly during the commercial mission. These include structural components, propulsion system, mechanical separation system, and all subsystems that operate during the launch. At our test facilities, In Teruel, this is in Spain, we have multiple test benches where we perform all these tests. These benches have systems that measure stress, vibration, and performance during engine ignition and structural testing. To run these tests, environments, especially is the important part of them, we rely heavily on any technology, especially Compact Rio, PXI, and LabVIEW. This platform, as the brain of our ground testing infrastructure, they help us to control the tests, acquire high-speed measurement data, and ensure that we capture everything that happened during rocket engine ignition or structural validation. Wow. We can iterate very quickly between testing and engineers teams with real data. This optimizes the development of the launcher components so that they can be retested in a very short time.
Yeah, I think we hear a lot about the test like you fly philosophy, and that just sounds so perfect for what you're trying to tackle here. But I'm sure with this level of complexity, there's almost no alternative for the safety and the performance that you are requiring. So how did you land on the NI platform to support that approach?
Yes, when you are developing rockets, you don't get chances to learn in flight. Yep. Everything has to be verified and re-verified before launch. Our test system runs complex validation procedures that simulate real operating conditions. We initially choose Compact Rio because it is rugged and we can use the real-time OS and the FPGAs to control test benches and simultaneously do the data logging in a single system. On some of the test benches, we have additional requirements and move to PXI for the same task.
Okay, so you're combining the strengths of both Compact Rio and PXI and using each where it's going to make sense for the control and the data collection.
Yes, and we collect a massive amount of data, from sensors like strain gauges, temperature sensor, and more. All of that data fit into our engineering workflow, so our teams can quickly understand how each component behaves and improve the design. And because the systems are modular and programmable, our engineers can evolve the test setups as the rocket evolves.
Well, and given how competitive and fast-moving that the space industry is right now, I'm sure that agility has to be really critical for you.
Impressive. For us, the biggest advantage is flexibility to scale. Our engineering teams design and automate test procedure in LabVIEW, which allow us to move quickly from concept to validation. Mm-hmm. When the rocket design changes, this happens all the time, we can adapt the test system without rebuilding everything from scratch. This approach has allowed PLD Space to scale our testing infrastructure as the company grows. What started with a single Compact Rio system years ago has grown into 11 test rigs and the dedicated team of LabVIEW developers building automated test capabilities. It means our engineers can focus on solving the hard aerospace problems, not reinventing the test infrastructure every time.
Yeah, and we know that strong engineering organizations not only invest in the technology, but also in setting up their people for success. Of course, we can talk about AI all day, but it's the engineers applying judgment and experience that make the progress possible. So how are you balancing those dimensions at PLD Space?
AI has a huge potential in our sector. In every simulation, test campaigns or flight, we generate thousands and thousands of data points. Not so long ago, analyzing all that data, information could take days or even weeks. With AI, we are very happy on that, that data can be processed in a much shorter time, helping engineers detect patterns, anticipate potential failures, and optimize design. In practical terms, that supports fastest progress and fewer errors. And for the next generation, this is the context they are stepping into. Engineers working alongside tools like AI to support better decision and optimize resources, making sure technology work for us, not the other way around.
Another very good quote we can put on the brochure there. Because I don't think we could have said that better. And I know you're doing more than just talking about it. So also tell us about your Ad Astra program, which is really cool.
Yeah, space, especially now, is one of the most demanding engineering fields in the world. And success depends on the people building the technology. That's why we actively recruit young engineers and train them in the technologies that we use, including LabVIEW. But you don't have to take my words for it.
Y creo que la innovación nace precisamente desde ese punto de partida, de aprender haciendo, preguntar, equivocarse y volver a intentarlo. Desde etapas muy tempranas, incluso con un perfil junior o de intern, tu trabajo tiene un impacto directo en sistemas reales que se diseñan, se fabrican y se testean. Como ingeniero de análisis de estructuras, he podido participar en la campaña de calificación del tanque de oxígeno líquido de la segunda etapa del cohete, donde he podido ver cómo la innovación se materializa en el día a día. Situaciones aparentemente simples, como que una válvula no funciona o una célula de carga que no lee correctamente, se convierten en una fuente de aprendizaje donde todos los departamentos aportan su granito de arena para llegar a la mejor solución posible. Durante este tiempo he aprendido a desarrollar soluciones novedosas y eficientes, y todo con una filosofía muy clara: probar, probar, probar y probar. Probar todos los subsistemas y probar hasta la extenuación. Gracias a instalaciones como las que tenemos aquí en Elche o en el aeropuerto de Teruel, somos capaces de ensayar a escala real prácticamente todas las semanas, lo que nos permite correlar nuestros modelos de cálculo y nuestras simulaciones con datos experimentales, obteniendo predicciones muy precisas.
Wow, this was fast,
Very cool. Yep.
So as you can see, the students' projects become real tools used in our facility. But building engineering pipeline isn't just good for good culture. If we want the space industry to grow, we have to invest in the engineers who will build its future.
It's very powerful. Pablo, congrats on everything you and the team have done so far.
Thank you. Vamos Liura, vamos Eni, vamos amigos.
Wow,
Thank you.
Excellent. Thank you. So if the last 2 days have made anything clear, it's that a new era of test is here. Leading in this era is going to require embracing the genius of the and. You shouldn't have to choose between what's proven and what's possible, between human judgment and AI, between speed and confidence, or between innovation and reliability. In every case, you can and must insist on both. And that's why platform strength matters so much in this moment. The systems you're being asked to build are only getting more complex and business critical. You need systems where speed and trust reinforce each other, and where intelligence is embedded into the workflow, not bolted on after the fact. You need the support of a platform designed to evolve as the technology landscape changes. The strength of the NI platform isn't any single product or feature. It's in the and. Hardware and software and data and an ecosystem, all working together as an integrated system. What we've seen today are just a few examples of what our platform vision enables. We've grown with every major shift in test and measurement, revolutionizing how you use technology to help you reach your goals. Over the past year, you've seen Nigel AI introduced into the NI platform, first as an advisor, and now with growing capabilities as an author. Soon, it will take on more agentic capabilities, enabling it to do even more, all designed to improve how you implement test and measurement in your organization, and proof that our platform is the most AI-ready because it was designed to adapt and evolve with technology. That's what it means to be ready for the new era of test. It's not that everything is new, but that the foundation is strong enough to carry us into the future. Productivity is no longer just about doing more faster. It's also about making better decisions in the face of more possibility. AI doesn't remove responsibility from you. You decide which problems are worth solving, which insights are worth trusting, and which actions come next. Reimagined productivity also means less time managing minutia and more time applying judgment. Faster learning, not just faster execution. Confident iteration, not just automation. It's productivity that delivers more discovery, insight, and real engineering impact. For more than 50 years, we've been with you through every major technology shift, enhancing our platform to deliver innovation in test and measurement. And we're not done. But before we move on to the rest of the conference, let's make a deal for the next 50 years. We'll bring the platform, the technology, and an incredible ecosystem of partners. You bring the curiosity, the passion, and the will to create what's next. Let's shape the new era of test together. Thanks, and have a great rest of the day.